Hello everyone. In the previous videos, we have already discussed about the linear regression algorithm. Okay. And then after linear regression, we have also discussed some of the data pre-processing techniques. So within data pre-processing, we have discussed about missing values, and then we have discussed about data encoding techniques. And finally, we have discussed about data scaling techniques as well. Okay. So these are the different things that we have discussed till this point. Now let's move on to the next thing. So if you guys remembered, within supervised learning, there are two kinds of algorithms. One is regression algorithms, and the other type is classification. Okay. So for regression, we have already discussed one specific algorithm, that is linear regression. Okay. So this is already done. Now let's look into some of the classification problems. Okay, so within classification, basically there are two types. One is binary classification problems, and the other type is multi-class classification problems. Okay, so what is binary and what is multi-class? By the name itself, we can clearly understand, right? So binary means that the output will be having only two classes. Okay, so if the output is having only two classes, then it means that it is binary class classification. And similarly, if the output is having either three or more classes, then we can say it is multi-class classification. Okay, so these are the two kinds of classification sub-problems. One are binary class classification problems, and the other class of problems are multi-class classification problems. And within binary classification, if you think of some specific examples, like there can be something like whether the student will pass or fail, that we wanted to predict with the help of the model. Then that is one binary classification problem. And similarly, if you are taking whether the email is spam or not. So this is one binary classification problem. And then there can be other examples like whether the patient is affected with cancer or not. So this is another binary classification problem. Like that, there can be so many binary classification problems. Now let's try to take one of these examples. Okay, so for now, let's concentrate on only binary classification problems, and let's take one example, that is this pass and fail. So in order to predict whether student will pass or fail, we can use one specific input feature, that is average number of hours studied in a week. And here, what will be our output? Based on this particular input, we'll say whether the student will fail or he will pass. And these are outputs, right? And these can be encoded in any way. We can use some kind of label encoding, and we can encode this to 0, and we can encode this to 1, or even we can encode them in reverse order as well. So basically, with the increasing number of hours, what will happen? The student will start passing, right? If he is reading lesser amount of time, then there is a higher chance of failing. And if he is reading more amount of time, there is higher chance of passing. So if we will collect some real world data, then how will my data look like? My data will be looking something like this. Whoever studied very little or very less amount of time will definitely fail. And there can be some people who are studying little more amount in time, even then they are failing. Like there can be some reasons. Now let's not go into that. But this is the real world scenario, right? So our data will be looking something like this. Now similarly, let's take about the passing condition. In passing also, beyond some certain threshold, all the people will pass. Like most of the people will pass. Only few people will be like less than this threshold also, there will be few people who will be passing. Like even he studied very less amount of time also, he got passed. So if you are thinking of some real world data, it will look something like this for this specific problem. Okay, so if you guys remember, in case of linear regression, what is the idea? The idea is to fit some straight line. Okay, so the idea is to fit some straight line for the points that we are having. So if we directly use that particular linear regression, then the line needs to be near to the most of the points. That is what the linear regression algorithm will do. Initially, the line can be in any way, but it will slowly adjust it in such a way that it will be near to the most of the points. So here, if we try to do that, then maybe our optimal line might look like this. Okay. So what is the problem with this particular line? The problem with this particular line is the output of this particular line can range anything between minus infinite to plus infinite. So you might be thinking, how is it minus infinite to plus infinite? Okay, so let's see. So let's say if this line is keep on extending, then for that extension point, like this is the y-axis, right? That is the output axis. It will be minus infinite if we extend the line. It is just a straight line. We can extend as much as we wanted. So if you are extending it, at some point it can go till plus infinite. And similarly, if we extend over here down like this, then at some point it can go till minus infinite. Like that, the output that is given by this line can range anything between minus infinite to plus infinite. What are the outputs that we are interested in? In case of binary classification problem, we wanted the output to be either 0 or 1. Okay, so or like we can take some other thing as well. Let's say if we are getting something in between these, like anything between 0 to 1 or minimum 0 and maximum 1. So if the output range is like this, then also it's fine, right? So we can think that it is giving some kind of probability score. So we can interpret it in that way. But here, if you observe, it is giving some number which is from minus infinite to plus infinite. So with this, we can't interpret them in some specific way, right? So that's why what we'll be doing, we'll be using some specific function which converts this whole minus infinite to plus infinite range to some 0 to 1 range. So let's think of such function. So before going on to the function, let's try to see the hypothesis of linear regression. So if you guys remember, in any of the algorithms, there are three main steps. First step is the hypothesis, and the second step is loss function, and the third step is optimizer. Okay. And if we come to the first step is equation of straight line, that is y cap equal to theta naught plus theta 1x. And what is the range of this? Range of this one is minus infinite to plus infinite. And we wanted it to be taken as input. That is, this line equation of line should be taken as input to some specific function, and the output generated by this specific function should be anything between 0 and 1. And the condition is that we don't want output to be alternating between 0 and 1. Like here, if you see, you can find some functions which can be alternating like this, okay, between 0 and 1. But we don't want such function because with increase in x value, let's say this is x and this is f of x. With increasing x value, I wanted the function also to increase continuously. So like let's say we are taking x to be minus infinite to plus infinite. As this minus infinite to plus infinite is keep on increasing, I wanted my function also to increase from 0 to 1 continuously. I don't want it to be alternating between 0 and 1. Okay, so that is the condition over here. So for which function these all conditions will be satisfied? The function is sigmoid. Okay, sigmoid function will satisfy all these conditions. So the first condition is it can take anything in the range of minus infinite to plus infinite, and it can map it to 0 to 1. And the second condition is it will keep on increasing. Okay, so as the value input values keep on increasing between minus 1 infinite to plus infinite, so in the similar way, the output that we get will also be keep on increasing from 0 to 1. So that is the sigmoid function. And let's try to see the graph of sigmoid function. So let's say this is x and this is y, and x can be anything from minus infinite to plus infinite, and y is nothing but sigmoid of x. So the corresponding sigmoid of x graph will look something like this. So here if you observe, this is 1 and this is 0. And if you observe, this curve is not crossing 1 at any point in time. And also it is not crossing 0 at any point in time. Like that, our output will be between 0 and 1. And if you observe, it is continuously increasing. Okay, it is not like alternating between 0 and 1. So such functions we are not interested in. So, and where it is touching this particular axis, it is touching at 0.5. So this is the sigmoid functions graph. And if we observe sigmoid of x formula, it will look something like this: 1 by 1 plus e power minus x. So this is the formula for sigmoid of x. Now, what will be my hypothesis for logistic regression? My hypothesis will be like y cap equal to sigmoid of theta naught plus theta 1x. Okay. So here, what is this? We can simply think of it as line equation. So we can say our hypothesis of logistic regression function is sigmoid of equation of the straight line. Now we can write it in several ways. So we can write it like this as well. Sigmoid of theta transpose x. Okay. Also we can write it as 1 by 1 plus e power theta transpose x. Like that, there can be several notations. So don't confuse with all these notations. All are same. Okay. So here we are just expanding it. It is some mathematical notation. Okay. So we can understand this later. For now, let's concentrate. And like this is our hypothesis. Okay. And after hypothesis, what is our next step? Our next step is the loss function. So in case of linear regression, what is the loss function that we are using? The loss function that we are using is mean squared error. And what is the like formula for that? It is I from 1 to n, summation of 1 to n, y minus y cap whole square. So what is this y? This is the actual output. And what is this y cap? This is the predicted output. Now, what do you guys think? Can we use this mean squared error? So, like, how many of you think that we can use? And if you think that we can use, then what is the reason? And similarly, if you think that we can't use, what is the reason? Can you please comment down in the comment section? And we'll be discussing this in the next video. Okay. Thank you, everyone. Bye bye.